Hello. We're starting with session now. Talk by Wasim Moosa. Open source approaches to a secure data exchange in SA's digital public infrastructure.
Good afternoon, ladies and gentlemen. Testing 1, 2. Got the opportunity to be the last talk of the day before the lightning talks. So I'm sure everyone is wide awake and ready to go. It's a bit deep, the talk, but I'm hoping open some minds into something maybe public citizens of South Africa haven't seen before. Open source approaches to a secure data exchange in SA's digital public infrastructure. Just by way of hands, who has heard of digital public infrastructure, or DPI for short? Got some city colleagues here, doesn't count. Okay, so my name is Wasim Moosa. I'm the CTO of Open Cities Lab. We are a non-profit tech organization working in the civic tech space, partnering very closely with government, but I'm not representing any government entity, and more from the perspective of the civil society organizations in this particular talk. So what is digital public infrastructure? UNDP defines it as a set of foundational digital systems that forms the backbone of modern societies. The way I like to think about it is much like roads. So just like how we have physical public infrastructure that enables access to other infrastructure, and you can do that by many different transportations when you use roads. You can do vehicles, cars. It's a mechanism to enable other infrastructure. So access to hospitals, to schools, to police stations, and businesses all go through roads. So while roads in itself is an infrastructure, it provides access to other infrastructure. So the building blocks of digital services. Taken from the roadmap earlier this year announced by our national government, it passed cabinet, I think, around in May, where they announced a digital transformation roadmap led by National Treasury, Department of Communication and Digital Technology, and the Presidency's Digital Service Unit. And basically, they took a step back and they said, what underpins all our digital services, especially at a national level, but across all government? And the persona drawn up here is Thandi, but you can imagine this being any South African. Wasim, insert name over here. Incomplete information about what services we have access to. We need to physically go into locations to get access to certain services. Most of it is done by physical copies. The services often aren't quick and don't meet our needs. And these are just day-to-day issues with digital services in our government. So DPI has 3 foundational building blocks, and that powers all digital services. There's digital identity, digital exchange or data exchange, and digital payments. To give an example, when one is going to renew their passport, we need to first verify that we renew it for ourselves, so provide some sort of identification. That ID then needs to be verified at Home Affairs. It needs to go through the data exchange to some government information system behind the scene to look at the population registry. That data exchange is extremely important because it needs to be secure, interdepartmental exchange of data between government services. And once that's done, generally there's some form of payment that's needed, and that again needs to flow through the data exchange. So pretty much any digital service, whether it's birth certificate, our IDs, licenses, so on, needs to go through some form of these 3 digital public infrastructure building blocks. Okay, so my focus is on the data exchange component. In the last 14 months or so, we've worked with national government very closely to prototype DPI, focusing on the secure data exchange layer and try to solve the problem that exists. But what is the problem? So government data currently exists in isolated silos. There's very limited access and integration to administrative data, survey data across departments. This all hampers streamlined research, evidence-based policy decision-making, government operations, and ultimately service delivery. One thing I did realize along the journey is there's not a lack of data. There's a lot of data. It's just locked up in silos and is available and is there in some format. So our road to a secure data exchange. So the challenge was set for us. We were approached by the World Bank alongside National Treasury and Stats SA to design the data exchange architecture. Initially, we received a brief around an integrated data lake solution. It was still very early phases, and some of the departments met and they discussed this particular bit of tech. But what was the challenge? We wanted to make use of integrated data from various sources for different purposes. We needed to consider how to actually access this data and how do we do this sustainably at scale. So you have operational data, real-time, openly accessible, and regulation, compliance, and verification data, which is identifiable data, our records, ID numbers, and so on. Again, this is government-to-government system, so we do comply with identifiable data. So the design journey was very comprehensive. We started with a needs assessment, good practice research at a high-level architecture, and evolving it through prototyping the architecture that was initially presented to us. Then we ended up with the final recommendation, which is what is most of this talk, where we'll go through the particular solution we sandboxed and is now moved into the pilot phase with national government. Okay, so the data lake investigation. This was very interesting. We received this brief, but firstly, what is a data lake? Very simply, a system designed to ingest just about any bits of data, structured, unstructured data. Supposedly very flexible and on-demand processing, and provides access to analytical data across various domains and diverse systems. The three architectures we looked at was centralized, federated, and hybrid approaches. Centralized system was initially presented as a way to move data from these national entities into a single place where one can access that particular bit of data. This was not ideal. Data stewardship and ownership and sovereignty is a big question. What happens if data leaks, especially in a centralized place? Who owns that? And who's liable for that? We then looked at a federated approach. It's oftentimes very good technology as well. And the federated system made a lot of sense. So move data into your own data lake in your own infrastructure. However, short term, we realized that this is not possible, especially those that weren't operationally ready with that bit of infrastructure. So a hybrid approach made a little bit more sense in the short term. So just quickly, advantages of the federated hybrid approach. Departments maintain ownership. That was one of the main things. Distributed data management allows the system to scale much more than a centralized system trying to scale. And we reduced risk decentralizing it across the department. The challenges we faced very early on was lack of consistency of format of data, especially when it comes to metadata. Large technical complexity in integrating all these disparate operational systems that are happening on a day-to-day basis. Has its own capacity constraints. So we took a step back and we said, okay, data lakes isn't working for us. It's a really good tech. It might be part of the ecosystem, but can we look at other countries and see what they have done? So we looked at about 5 or 6 case studies in particular out of 15, and these are the 4 that came quite high. There's actually one more on the next slide. Rwanda's Irembo platform, Brazil's gov.br, and UK's data.gov.uk, all amazing systems, but were more targeted at the citizen digital service side rather than the exchange. India's stack was very interesting, had a lot of good API templates available, and is used in India at scale. However, we didn't find implementations in other countries around the world. So then enter X-Road. Estonia's X-Road, a secure decentralized data exchange platform enabling seamless interoperability across public and private sectors. Almost fits our requirements exactly. The identities are maintained centrally, but all the data is exchanged directly between a service consumer and a service provider. So centrally managed, but federated in exchange of data. That'll become more apparent a bit later down in the architecture discussion. But Estonia's X-Road's been in production for over 20 years. It's been implemented in 25 countries across the globe. And it's also in Finland for 10 years, so over a decade over there, and in Iceland. Okay, so as mentioned, established first in Estonia in the early 2000s. I think it was like 2002, somewhere around there. 99% of services of Estonia are digital. That was amazing when we were speaking to Estonia's XT implementation, which is what they call X-Road. They showed us their app. Everything is digital. The last 1% is a physical copy of your death certificate. That's all that's left. Copy of any of their digital services. We got a bit of time. I have one question for the audience at the end over there on what if they get cyber attacked? What happens to all their digital services? Okay, X-Road. So the X-Road ecosystem, same instance of the X-Road software for producing and consuming services. The X-Road operator controls who joins this community or this ecosystem, and they define the regulations and practices, but they don't control daily operations or movement of data. Before we could move forward, we really had to take a step back yet again. And with government, open source software is often not easily digested, let's put it that way. And sometimes it's a reality because it does come with some setbacks, which we've seen over the last decade. You know, who's going to maintain the system? Where are the updates going to come from? License fees, like that's the first one we get asked. What's the license fees for our open source software? So we did some thorough research behind the scene on X-Road. So it's run by the Nordic Institute of Interoperability Solutions, or NIS for short. They are member organizations of, or this is a non-profit organization that has 3 countries as their members, Iceland, Finland, and Estonia, but has other 10 member countries sitting, I think, on their board. So they're well backed. X-Road is currently on version 7, again in production for over 20 years. It complies with relevant standards and security requirements. This was a big one, GDPR compliant, and by some extension, POPIA. And they have a high level of standards in terms of their 509 PKI and TLS certificate requirements. And it's passed many third-party audits from different countries across the years. It's interoperable by design. I'll explain X-Road Federation in a bit, but it's more than just department collaboration. It can even go cross-border and cross-country collaboration. They had extensive official documentation for the public. We could get a hold of the CTO fairly quickly. He's available on Slack, almost like tech support, and I don't know where he gets the time. But one has to fill, or this commercial partner network of X-Road, one has to fulfill like very strict requirements. But not as much as towards the code. Yeah. Oh, okay, sorry. Yeah, so to become a commercial partner of X-Road, you need to contribute towards the code. You have to have one country level, is it too loud? Is it okay? One country level implementation, or at least, I think, provincial level, before they even decide to accept you in the criteria and start to like interview you officially. This was something that came up, which I saw recently, and I think justifiably, in the last 10 years of working in the open source space, I think it's put very well. Too often, open source solutions are expected to be implemented by an in-house team that in practice lacks mandate or resources to sustain them. So moving from I have a proprietary solution and I am the only one to implement it, to I have an open source solution and you are the only one who can implement it, is some progress, but is still not enough. What we really need is an active tech ecosystem for reliable implementation partners. Okay, so on to X-Road, the analogy that makes it click. So think of X-Road as a secure national rail system. When I was explaining this to my 2-year-old daughter, and I told her about the train system, she was very impressed and highly enthusiastic, so I'm expecting the same response. Fortunately, I had to buy her a train. So imagine X-Road as a secure national rail system where your information systems equals office buildings. It's where you actually carry out your business processes. You have your operational databases being stored at departments. In this particular example, we're looking at hospital needs a tax record, and a tax authority like SARS can supply that bit of tax records. So in this particular ecosystem, these systems never directly connect to each other. They send a request to their local train station when they need external data. The train stations are security servers in the ecosystem. Each organization has to set up its own station or security server. All data must pass through these stations, so no direct building-to-building access. Stations handle security checks, tickets, authentication, routing, and just like train stations, they are controlled entry and exit points in the network. The data equals passengers and cargo, so your actual information, citizen statistics, de-identified data, and even identifiable data travels through the network or as passengers or cargoes in this example, in secure sealed containers, encrypted messages, has a ticket showing the origin, destination, and purpose, never leaves the train station exposed, so you know which organization or member organization has requested the information and who has received produced the information. The central server is much like a national rail authority. It maintains the master timetable of all these train stations, issuing operating licenses, certificates to stations. It doesn't control daily operations, but sets the rules. It's a distributes network map, so every station knows available routes. So no department can just put up a train station and just be part of the network. They have to officially register with the National Rail Authority here or the central server. The network is equal to rail tracks, the secure communication protocols connecting all stations, standardization track gauges, so over the network, built-in safety systems to prevent collisions or duplicate messages, and multiple routes for redundancy. So here's an end-to-end request that happens throughout X-Road. A hospital would send a request to their station, would know the destination to be sent to SARS train station, who would then process the record and send it back. Bottom line, X-Road creates a trusted transport network where organizations maintain their own secure entry-exit points, data travels in standardized and secure containers. A central authority maintains order without controlling the data, and everyone can reach everyone else using the same system. It's efficient, secure, and standardized data exchange across an entire nation's digital infrastructure. So we're going to do a deep dive into the technical architecture shortly. The train station example was very simplified. And what were our final recommendations about 2 months ago before we moved into the pilot phase last month? So in terms of the technical architecture, federated data exchange was ideally recommended with centralized coordination, and a hybrid implementation just for the short and medium term, ultimately hoping for federated in the long term. This balances department data sovereignty with secure cross-government data exchange through a structured framework. I'll have to say here that we're focusing on the tech But as seen later, there's many other streams alongside the tech to make this happen. So the key components are your data exchange, data owner, and data consumer, cross-cutting standards and policies for compliance and legislative requirements, and uses X-Road as a foundation. All right, so we'll go into the deep dive into the technical architecture. On the right and left-hand side, you have your data provider internal environment and data consumer internal environment. This is already there. It's happening on a day-to-day basis with each government organization, and there's a lot of data already being processed in these spheres. So where X-Road comes in and puts in some standards, or at least starts its responsibility, is every department that wants to connect up to X-Road has to set up a security server. And they have to register the security server with the central server. So much like your train station, you can't operate without that license. How that looks in practice is you issue an actual TLS certificate that's given from a trust services, which I'll mention in the next slide. So you set up a security server that's gateway and access to your infrastructure, and you register that with the central server. The central server is purely there for registration purposes and the member organizations and their security servers. So SARS, however many security servers they have, Stats SA, National Treasury, and so on. The central server also keeps a registry of all the trust services. So part of this is a certification authority and a timestamping authority. That'll be more apparent in, the timestamping authority will be more apparent in the next slide, but certification authority issues TLS certificates to the security servers to say you can operate in this particular network. Let's jump on to the next one. So if there's data exchange happening, where's the standardization? One is the protocol. X-Road supports only REST and SOAP protocols for data exchange through the security servers. And predominantly we've seen real-time exchange of data rather than bulk data moving through the network in other countries. Part of this is the second certificate the security server holds, and that's a signing certificate to encrypt the outgoing request. So there must be some API standards that is serving data in the operational databases or the data provider environment. I think what's really nice about this is you have a metadata catalog available to everyone who's connected to the environment. In the environment, you can see every information system that's available in the environment. You can see its metadata, but you can't have access to it. You still have to go through governance, legal, and some sysadmin to get access to that particular API endpoint. So it's not like if we connect up Home Affairs today, all their systems just become enabled, even if they have API endpoints. They can limit access if they want on their security server and have fine-grained access or access controls into their network. Let's go to the trust services. So the trust services play a crucial part in here. It forms under the public key infrastructure initiatives of X-Road, where your certification authority acts like your commissioner of oath to some extent. It can be a third-party provider or built by government, but in short, much like your TLS certificates on the web, X-Road slightly differs where it requires even more specific attributes in the TLS certificate, so you can't just use like let's encrypt off the shelf. This has to be something custom built in terms of a certification authority. And as mentioned, they have to register with the central server to be part of the network. Any certificates issued to a security server that's not from that certificate authority obviously will be rejected. Timestamping authority comes into place when there's real-time exchange of data. So it'll just timestamp the outgoing request at a particular time. Something very interesting the CTO mentioned on our last call was the X-Road implementation one record got called in a court case, and the timestamp was relevant to the record being brought as evidence. So it's just a reality of where, having a full audit trail of the data going in and out, even interdepartmental sharing of data is very important. Okay, so we've touched quite a bit on the tech. In terms of other streams that are going on, there's a mandate, compliance, and rights protection. Obviously, throughout this, where entities shouldn't receive identifiable data, we need to protect, firstly, our rights as citizens for opt-in and so on. But also, there needs to be a mandate in the government sphere to use the data exchange and also exchange data. So memorandums of understanding is very important. And there's a large amount of work happening to make sure mandate and compliance happens alongside the tech. Okay, so the pilot phase. There's already a high fidelity sandbox built on AWS with quite a few information systems exchanging data. It's mostly dummy data that happened in the prototyping phase. We've already moved on to the pilot phase where SASA is being onboarded and a few other departments. And that started last month. In fact, the official announcement happened yesterday in Pretoria. And I think as a citizen looking from the outside, it was quite positive to see some of behind the scenes, the work going into making, hopefully, our digital services a lot better. I'm as skeptical as everyone's face in this room, but just a quick look into the future, where we're going with all this. So XT, or Estonia's X-Road implementation, showed us an example of 1 month's query within their data exchange. And you can look at their popular data services, health data being the most popular. I mean, throughout health and healthcare, you're looking at about almost 60 million queries in the last month. Business registry and population registry also very high up there. Just as a general note, Estonia's population is only 1.5 million, so we can't infer exponential increase here, but at 60 million, I'm assuming that we'll have a lot more queries. Okay, thank you so much. And these are the websites if we want to find out more information, all publicly available, and we're doing our best to work in the open. Any questions?
Firstly, I think you chose a great solution. Secondly, when can we expect this to roll out to everyone?
I can't make promises. The pilot phase is 1 year starting last month, where they want to onboard, I think, 4 main departments that they have prioritized, which are like organizational ready in terms of having APIs ready, mandate, and governance, of which 3 are, Home Affairs, and our top 3 we'd expect to be onboarded. Just to note that the data exchange facilitates it. There's already happening a lot in their ecosystem to enable data. So a lot of the work is not around X-Road itself, but around bringing departments up to standards such they can share data through the network. So X-Road isn't an all-out solutions for APIs. It's just to provide the network and the transport layer. So a lot of work to be done.
Great talk. Thank you for that. I have 2 technical questions. One, when, say one system requests data and they consume it, whether it's real time or they do a bulk load, is that then cached in that system for later use? And then second question, does X-Road, or at least the X-Road implementation that we're working, or that your team is working on, does it include some, considerations for backups when, say another system, critical system goes offline and you aren't able to query that kind of data?
Yeah, it's an excellent question. Again, we looked to implementations already in production, and we saw a mixture of infrastructure that's been implemented. So for example, in Estonia and Finland, we saw bare metal implementations with like hardware load balancers. And when we look to Brazil and Benin's implementation, it was more classical private cloud implementations. So either way, backups is part of the infrastructure. High availability is going to be a big one. And while we can make it look really good on AWS and all these third parties, there's a lot of work to be done when it comes to real implementation on government infrastructure.
First question, I'm not sure if you answered that.
Sorry, what is the first one?
I'm not sure. The first question was, once the data is consumed, is there like a policy in place to store that data, or should it be like deleted after it's consumed?
Yeah, so that's actually more on the governance and legal side of what they can do with the data before even X-Road gets involved. So if a department can exchange data with Home Affairs, there'll be some terms and conditions on how long they can store that data and what purposes they can use the data. So they would have to enforce that on their information system or be held, to legal.
Hi, just a quick one, because you did mention cloud versus on-prem type things. Are you seeing any trends in the cities that are picking this up and them switching to cloud or switching back to on-prem?
At national, I would say with CETA and stuff, it seems to be 90% on-prem, 10% in the cloud. At the city level, there's other people that are more experienced than me that can give.
Okay, fair.
But I would say still 90% on-prem and 10% in the cloud. But it also depends on what you define in cloud, because there's like NICAS, the Center for High Computing, who presented earlier today, and they've got their own infrastructure in the cloud, but it's on-premise available for government use. But I would say 90% on-prem.
So it's just to answer the question. So we partner with government as the local cloud provider on which your application resides. So to address the data sovereignty issue, the Azure applications actually is loaded and developed on our cloud platform down in Cape Town. So I just want to add to that. Thanks.
Okay.
Thanks, Wasim. It was a great talk. I just wanted to ask, like, what was maybe one or two of your greatest challenges in like bringing the South African context together and implementing this X-Road within its laws and regulations, and maybe also like once completed, what would how would the average South African's life be improved after this?
Yeah, I mean, it's such a good one. It's like our impact pillar from the nonprofit side. So ultimately, service delivery should be streamlined as an output. That's the end goal of all of this. If you go, you shouldn't need to go into Home Affairs. You should have an application ready to exchange data with a digital ID available on your phone. Again, we're building the foundational layer, so maybe you can say baby steps, but there's a lot that can be built on top of that. For example, commercial bank providers also, or any commercial providers, will need to be building on top of this for gathering data. I didn't touch on digital IDs and digital payments. There's a lot happening in that sphere. And the presidency's new unit is doing a good job behind the scenes to coordinate national initiatives. So I think the pessimist citizen in me that would have not seen all of this would have been like, we're never getting it. But I am a lot more optimistic. Just in terms of departments and their readiness, we've got tech readiness, we've got legal mandate readiness. It just depends where they are. Sometimes it's like they're not fearful to build. They're worried about like dirty laundry or how their systems are built and how bad they are. But as soon as you start putting things into the public, making it available and transparent on how you got there, I think it builds a lot of trust. But yeah, it's a culture change rather than a tech.
I think we still have time for one last question. 2 minutes left.
I'll just touch on the federated one very quickly. So cross-border communication is already happening between two different X-road systems, between Estonia and Finland, actually 3 countries. So when it comes to federated approach, you can go cross X-road implementations, but we've also seen in Argentina where they've got multiple X-road implementations in one country. And I think that was more for political reasons and you know, departments wanting to hold ownership of all components of the X-road. But the nice thing is, because it's federated, you can connect up multiple instances. So even in that case, where they got 8 implementations, which is not ideal, they're still able to collaborate with each other. Yeah. Thank you so much.